Assalamualaikum warahmatullahi wabarakatuh. Our final year project is portfolio optimization by using Mean-Variance model and Mean Absolute Deviation model. And we are supervised by Dr. Mazna Banu binti Muhammad Habibur Rahman.
I'm the group leader. My name is Afika Atira binti Rahman.
Assalamualaikum. My name is Nonadirah binti Nasaruddin.
My name is Nurin Izzati binti Muhammad Razali. Abstract. Portfolio optimization is an important asset allocating strategy to minimize portfolio risk. We did research portfolio optimization by using the Mean-Mean MV model and Mean-Mean Absolute Deviation MAD model. We have constructed optimal portfolio by using SL optimizer. Next, the performance of MV and MAD model were constructed in terms of risk, variance and MAD, and realized return from low at 0.5%, medium at 1.5%, and high at 3%. Introduction. As stated by Kamal 2009, Markowitz used the concept of risk into the problem and introduced a mean risk approach that identifies risk with the volatility variance of the random objective. As time has passed, Markowitz has not been used because of the difficulty in estimating the correlation matrix and computing the quadratic programming model. Then, MAD as an alternative to Markowitz's MV model, use MAD as the risk measure to estimate the nonlinear variance-covariance of the stock in the MV model. It transformed the portfolio selection problem from quadratic programming into a linear programming model. Problem statement. Portfolio optimization is needed in decision-making to determine the problem of uncertainty of future return by using MV and MAD model. Objective. First, to minimize the risk measure in the investment portfolio for better return using MV and MAD model. Next, to analyze the behavior of risk when minimizing the MAD model in the MV portfolio and minimizing the MV model in the MAD portfolio. Significant and benefit of the project. This research will help researchers to gain more knowledge in getting a portfolio that will evaluate the maximum possible expected return while maintaining and minimizing the amount of risk they could bear. Scope and limitation. Data has been taken from Yahoo Finance and it consists of 14 stocks in Malaysian stock market. The data has been compared within 7 years and it was implemented using Microsoft Excel. The main limitation is data limitation.
Literature review. First, Weng Ho 2010 proposed that variance as the most common risk measure used in portfolio optimization through the MV model. Then, Fabozzi 2012 discussed about the diversification concept in the MV model. Next, Baghi and Konak 2016 claimed that MAD model was a simplification from Markowitz's model. Meanwhile, Zhang 2016 discussed about the favorable properties of the MV model were maintained in the MAD model, but it removed the difficulties in solving the MV model. Lastly, Mbah and Workway 2016 has stated that a linear programming method also for optimal financial investment in developing economy. This research focused on constructing a portfolio that was to maximize profit at a most minimal risk level by allocating each stock which made the right choices of assets and the right fraction of investment funds.
Next is methodology. The flowchart starts with data acquisition, second phase is portfolio optimization, and the last phase is backtesting. We move to the first phase, which is data acquisition. In this research, the data was taken from Yahoo Finance for 14 assets to generate scenarios returns. The given data were compared within 7 years or 84 months for each asset. Below is the list of 14 assets in Malaysia. Next, second phase is portfolio optimization. We applied the MAD model from Kono and Yamazaki 1991 and MV model from Markowitz 1952 by minimize these equations. We construct 10 in-sample portfolios using the first 70 scenarios for in-sample A, second 70 scenarios for in-sample B, and the process continues until we obtain 10 in-sample portfolios. The concept of rolling windows is applied in the process. We also categorize the portfolio construction at 3 levels of target return, which are low, medium, and high. Lastly, we analyze the portfolios in terms of their risk measure, which are standard deviation and MAD. Last phase is backtesting. We calculate realized returns to validate portfolios construct in the in-sample analysis. Then, we compare the estimate and realized returns from the out-of-sample analysis. And lastly, as 10 optimal in-sample portfolios are constructed, we backtest the results obtained 10 times to determine the consistency of the portfolios.
Results and discussion. These are the results and discussions for minimizing risk. The figures shown the risk minimizing in M-MAT and MV models for the three different target returns, which is 0.5%, 1.5% and 3%. The risk measure of standard deviation and mean absolute deviation for constructing optimal portfolios are being minimized to obtain variance minimizing portfolios and MAD minimizing portfolios respectively. Based on the two figures shown, we had analyzed that both variance and MAD minimizing portfolios have shown similar results for the three different target returns. However, we also observed that MAD minimizing portfolios had smaller risk values compared to variance minimizing portfolios. Thus, based on the results obtained, we have concluded that the higher the target return, the higher the risk minimized for both minimizing portfolios.
Analyzing the behavior of risk. By using 10 in-sample portfolio, we can observe the behavior of variance minimizing MV and MMAT portfolio. The figure shown, in all levels of target return, the variance minimized the risk better in the MV portfolio compared to in the MMAT portfolio. There was a slight difference in the value of risk for the variance being minimized in the MV portfolio and MMAT portfolio. Next, we also observed the behavior of MAT minimizing MV and MMAT portfolio. The figure showed that MAT minimized the risk better in the MMAT portfolio compared to in the MV portfolio for all levels of target return. There was a slight difference in the number of risks between the MAT minimizing in the MV and MMAT portfolio. Hence, MV and MMAT will minimize the risk better in their own portfolio. It is because MV model minimizes variance and MMAT model minimizes MAT.
Next, to strengthen our results, we apply equally weighted portfolios to compare with the MV and MMAT portfolios. EW portfolio means the invest capital is shared equally for all assets. Below is the table for risk measure, standard deviation and MAT. The results shown, EW portfolios have a higher risk than the MV portfolios and the MMAT portfolios. It was true because EW portfolios did not minimize or maximize returns when constructing it. Lastly, for the backtesting, out-of-sample portfolios were constructed using 30 scenarios from the set of data used in this research. Here is the realized return for in-sample C as reference. The results shown, the MMAT portfolios capture the higher returns as the target return increase. The MV and MMAT models minimize variance and MAT respectively. However, it was only favorable for lower target return. The minimum and maximum values are obtained from the portfolio return. For Sharpe ratio, MMAT portfolios give the highest value at the lower target return. Hence, it has a better risk-adjusted performance. We can conclude MMAT portfolios outperform MV portfolio at low target returns in terms of their risk measure and return of the portfolio.
Conclusion. Two main objectives were achieved in this project. First, we had minimized risk in the MV and MMAT models. Similar results were obtained for the three different target returns, but smaller risk values acquired in MAD minimizing portfolios. Second objective, which we had analyzed the behavior of risk when variance minimizing MV and MMAT portfolios and MAD minimizing MV and MMAT portfolios. As a result, variance achieved a minimum risk in MV portfolios while MAD achieved a minimum risk in the MMAT portfolios. It was because MV model only minimized variance and MMAT model only minimized MAD. Overall, we have concluded that both models have their own specialties in minimizing risk. Recommendations. Firstly, use other optimization models such as Mean-Var or Mean-Var. Second, test with different portfolio models by varying size, periods or markets. Lastly, implement portfolio optimization on the same models but with different softwares such as MATLAB, AMPL or Maple.
Thank you.